FastMCP 3 implements a discovery-driven tool composition mechanism through CodeMode, which exposes meta tools for dynamic catalog inspection and sandboxed execution. This transform layer abstracts direct tool access, replacing it with a three-stage workflow: discovery of available tools, retrieval of parameter schemas, and execution of composed tool chains in an isolated environment. The upcoming artifact demonstrates how to extend this discovery system by creating a custom tool that lists all available tool names, integrating it alongside built-in schema retrieval. You'll observe the pattern for defining discovery tools as functions that receive a catalog accessor and return a tool instance, with the inner functions docstring serving as the tool's description for the LLM. From FastMCP Experimental Transforms CodeMode, import CodeMode. From FastMCP Experimental Transforms CodeMode, import getToolCatalog, getSchemas. From FastMCP Server Context, import context. From FastMCP Tools Tool, import tool. Def list all tools getCatalog, getToolCatalog tool. Async def list tools text, context SDR. List all available tool names. Tools equals await getCatalog text. Return, joint name for T and tools. Return tool, from function fin equals list tools, name equals list tools. CodeMode discovery tools equals list all tools, get schemas. This code demonstrates how to create custom discovery tools in FastMCP's CodeMode, specifically focusing on the getToolCatalog dependency injection pattern. The listAllTools function takes a getToolCatalog, callable as input, and returns a tool that, when invoked, retrieves the full tool catalog through the provided function and returns a comma-separated string of tool names. This pattern allows for request-scoped catalog access, where different users might see different tools based on authentication or session context. The implementation follows FastMCP's transform pattern, where components flow through a pipeline of modifications. Here, listAllTools acts as a server-level transform that modifies how tools are discovered. By using toolFrom function, it creates a tool with an explicit name, listTools, that will be exposed to clients. The inner async function, listTools, receives a context object, enabling access to MCP capabilities like logging or resource management during execution. This approach provides flexibility in tool discovery while maintaining the pure function pattern for listing components. The custom tool integrates seamlessly with built-in discovery tools like getSchemas, as shown in the CodeMode initialization. The design choice to use dependency injection for catalog access rather than direct access enables better testability and supports scenarios where tool visibility varies by session or user permissions. Let's break it down. From FastMCP Experimental Transforms CodeMode, import CodeMode. Imports the CodeMode class from the FastMCP Experimental Transforms module, enabling code transformation capabilities within the FastMCP framework. From FastMCP Experimental Transforms CodeMode, import getToolCatalog, getSchemas. Imports two experimental transform classes from FastMCP's CodeMode module: getToolCatalog for retrieving available tool catalogs and getSchemas for accessing schema definitions. These are likely used to inspect or modify tool and schema components as they flow through the transform pipeline. From FastMCP Server Context, import context. Imports the context class from FastMCP Server Context module, providing access to MCP session capabilities like logging, progress reporting, and resource management within FastMCP components. From FastMCP Tools Tool, import tool. Imports the tool class from the FastMCP Tools Tool module, providing the base class for creating tools in FastMCP 3. This class enables the definition of tools that can be exposed via MCP Modular Component Protocol with configurable names and context access.
Def list all tools get catalog. Get tool catalog tool.
Defines a function named listAllTools that takes a parameter getCatalog of type getToolCatalog and returns a tool object. The function signature indicates it will use the provided catalog retriever to generate or fetch a tool, but the implementation details aren't visible in this segment.
Async def list tools text. Context SDR. List all available tool names.
Defines an asynchronous function named listTools that takes a context object as a parameter and returns a string. The function is documented to list all available tool names, suggesting it will generate a string representation of tool names when invoked.
Tools equals await get catalog text.
Asynchronously retrieves the tool catalog using the provided context, CTX, and assigns the result to the variable tools. The await keyword indicates this is an asynchronous operation that will suspend execution until the catalog is returned.
Return, joint name for T and tools.
Joins the name attribute of each tool in the tools iterable into a comma-separated string. The generator expression, tname for T and tools, extracts the name property from each tool object, and join concatenates them with commas and spaces between each name. The result is a single string listing all tool names.
Return tool. From function fin equals list tools. Name equals list tools.
Creates and returns a tool instance by wrapping the listTools function, explicitly naming it listTools for exposure via MCP. The from function class method converts the provided function into a tool object, using the specified name instead of defaulting to the function's name.
CodeMode discovery tools equals list all tools. Get schemas.
Creates a CodeMode instance configured with two discovery tools, listAllTools and an instance of getSchemas. The discovery tools parameter defines which tools will be available for discovering components in the FastMCP system. FastMCP 3's discovery-driven tool composition shines through its dependency injection pattern for catalog access, demonstrated by the listAllTools implementation. The key insight is how getToolCatalog enables request scope tool visibility while maintaining pure function semantics for tool listing. By wrapping the async listTools function in tool from function, we create a discoverable tool that integrates seamlessly with built-in components like getSchemas. The CodeMode initialization ties it all together, showing how custom and built-in discovery tools coexist in the transform pipeline. This design choice, using injected catalog accessors rather than direct access, enables both testability and dynamic tool visibility based on session context, all while preserving the clean separation between discovery and execution phases.
The context embraces every tool yet vanishes until a whispered name summons them from the void.